Hi friends, welcome back to Codelligent. In this video, we will be looking at one of the important topics when it comes to programming in any language, that is exception handling. So let's get started. So first of all, we'll try to understand what are exceptions. So exceptions or errors are the issues which are caused at runtime. And when an exception occurs at runtime, the code will stop executing and terminated abruptly. So that means if you have 100 lines of code and in any of the code line you get an exception, the further lines of code will not be executed and the program will be terminated, which is actually bad for any of the applications. So that is why in almost all the programming languages, you have a concept called exception handling, so that you can handle the exceptions which occurs at runtime gracefully and your application doesn't crash. In Python, to handle exceptions, we have try except block. People who are coming from C# or Java background, they might be familiar with try catch block. So here in Python, instead of catch, we have except. So there are other blocks which are also available. We have 4 blocks which are available in Python: try, except, else, and finally. The code in which you think that there can be an exception at the runtime, that you would like to enclose in try block. And it's a good practice when you are programming that you narrow down the code which can cause exceptions. So for example, if you have 10 lines of code, instead of putting all the 10 lines into try to segregate it and try to narrow down to such statements which you think are potential of causing exceptions, and only those you want to enclose inside a try block. And for a try block, you can have one except block. So whenever there is an exception which occurs in the code which is written inside the try block, automatically the execution goes into except block, and where you can write the code to handle that exception. So in a case there is an exception, what should be done? That code needs to be written inside the except block. And it need not be that there should be only one except block. There are scenarios where you will need multiple except blocks that we will see once we get into the coding. And we have else block, wherein this particular code, whatever you are putting inside the else block, will be executed only if there was no exception was thrown in the try. So you have a try, except, else, and there are code inside all these 3 blocks. When an exception occurs in try block, except block will be executed and else will be skipped. And if there was no execution in try block, everything went well, then exception block will be skipped and only else block will be executed. And apart from that, we have finally block, wherein you put some code which you think must be executed in any of the scenarios, whether an exception occurred or not. In both the scenarios, this particular code should be executing, then put that in the finally block. So usually in real-time programming, the finally blocks are used when you are dealing with files or DBs. That is like when you open a file and in between whether an exception occurred or whether the exception didn't occur, finally you are supposed to close the file. Similar to that, if you have started a connection to a database, then irrespective of whether an exception occurred or not, finally you should be closing that connection which you have opened with database. So such kind of code, usually we put it inside the finally block. So let's try to understand these blocks and how the execution happens with the help of a code. So we are in our IDE, Visual Studio Code, and I have a new py file. And first let's see how an exception looks like. So to generate an exception, I can simply say print a. And here, since you are in IDE, it already shows a squiggly line here wherein it says a is not defined. But we can still go ahead and execute it. So let me execute this file. And you can see it gave an exception at this particular line. So you can see it is name error, saying name a is not defined. So this particular crashing of application is known as a runtime exception. So for example, if you have a line of code below this, all done. So, and if you try to execute this, so you can see this particular line of code, the last print was never executed. The execution got terminated at line number 2 itself, which is actually a bad scenario. And whenever there is an exception, you should ideally, instead of getting the application crashed, you should handle it gracefully. So now to handle this scenario, Let me first put a statement on the top it also, so that you get the understanding of how the flow is happening. So first line, and then one statement which creates an issue, and one last statement. So let me quickly execute this, and you see first line was executed, but in the second line there was an exception, so the third line was never executed. So now let's handle this exception. So now when you enclose this particular block, because you know this is the potential statement which can cause an error, so you enclose that in the try, and in the except block you say print an error was thrown. So now you see the difference when you execute. You can see first line got printed. In the second line there was an exception, so it went into the except block and it printed an error was thrown, and the execution continued. So that's why you are able to see the third line which is printed. So this didn't crash your application, whereas it handled the exception gracefully. This is a very simple scenario. Definitely you will not be writing like this, but there will be scenarios which might occur on runtime and you don't know while coding. Based on the user input also it might come. So such statements are the potential statements which can throw exceptions. For example, you are taking input from a user and you are trying to convert it into some data type, or you are trying to read some file and there might be chances that the file was not generated and the file doesn't exist. So such scenarios are the ones which you don't have a control over it, and that will be decided once the program is running and run the runtime. So such statements are good to be put inside the try block. Now, as I said, there can be multiple except block as well. So for example, in this you saw that this particular statement, which is print of some unknown variable, throws a name error. So if you know the type of the exception which can occur, then you can have one more except block here specifically for that type of error. So I'll say except name error, and I can have some code here and say the variable is unknown. Now you have two except blocks. One is very particular to name error and one is general. So if in the statements which are inside the try block a name error type of exception occurred, then only this block will be executed and this second except will be skipped. But if the exception occurred in this try block is not related to name error, it is some other type of error, then automatically the except block, which is a general block, will get caught, not this will be skipped. So now in this case, when I execute, you can see the variable is unknown is printed. That means it has gone specifically into name error. So now you might think, how will I know what all errors occurs? So for that, you have a dir command which we have seen in one of our previous videos, and for that I'll just take you into the idle shell. This can be done also in Visual Studio Code, but there you cannot directly execute dir. You'll have to enclose the whole dir command inside a print. So to check that, you can just say dir, and inside you can type underscore underscore built-ins underscore underscore and close the bracket. And when you press enter, you can see all the built-in types of function or errors, classes, everything has been defined, whatever is already built in. And here you can see anything which ends with an error is nothing but of an error type or an exception type. So for example, arithmetic error, assertion error, attribute error, and you can see blocking IO error, you can see import error, you can see IO error. So there are so many errors, and you can see here also we have our name error. So these are all different type of errors which are available. So for example, you have one more called zero division error. So now in our code, I can say here x equal to 3 divided by 0, and I'll print x. So now in mathematics, you know very well that something cannot be divided by a 0. And now if I execute this, you can see it didn't go into the name error, whereas it went into the except block and it printed, because 3 by 0 will raise zero division error. So you can see here it's a zero division error. So now if you want to specifically catch, you can have one more except block and you can say zero division error, and you can print saying divide by 0 is not allowed. So now if you execute this, instead of going to except block, it will specifically go into the zero division error block and it will print divide by 0 is not allowed. So this is how you can have multiple except block for your try. So based on the number of code here, you can think like there are chances that this error can occur from this statement whenever the user is giving the input, and he might enter 0, and in that case this could be an error. There can be a scenario wherein something else, some other statement can cause something else. So in that case, this kind of different exception will help. So this might be not a good scenario to show like how multiple exceptions can occur at runtime, because here we are hard coding the stuff. So let's see a good example where this kind of scenario can occur in real time. So let me change the first line saying division of numbers, and here I will say, maybe outside the try, first I'll say num1 equal to input enter first number, and I'll say num2, and I'll just copy this, and I'll say input second number. So now inside this, first I have to convert these into int type, because by default the input will give me a string type. Now when I say a is equal to int of num1 and b is equal to int of num2, and then finally I'll print a divided by b. So now what do you think, what are the potential errors which can occur here? First thing, if the num2 has been entered as 0 by the user, then there are chances that zero division error might occur. You have to have one except block for zero division error. Apart from that, there are chances that user might enter a non-numeric value. So for example, I am saying enter first number, and since it accepts a string, I can just type ABC, and when you try to convert into int, then it will throw a value error. So let's see how that occurs. So maybe if I'll just remove these two as of now, and I'll keep this. So first trial wherein it says enter first number, I say 3, enter second number, I say 0. Now it says divide by 0 is not allowed. So this is good to handle this kind of execution. But what if the user enters first as 4 and second as ABC? Now the application crashes because it's a value error saying invalid literal for int with base 10. So now ABC cannot be converted into an integer type. So it throws a value error. So there is one more potential exception which is possible inside these statements. So for that we need to have one more except block, and we should say value error, and I'll say print only numeric values are allowed. So now if I execute this, both my scenarios are handled. If I say the first one as 4, second one as WE, it will say only numeric values are allowed. So this is how you have to narrow down the code and find out what kind of exceptions this particular codes might throw, and based on that you have to narrow down what kind of errors it can cause. And maybe as a safety net, you can always have an general except block saying print some unknown error occurred. But in general, when you are coding for a real-time application, you don't usually use these kind of except, because some of the exceptions will go unnoticed, because it might just throw an error and it will show to user some unknown error occurred. But ideally you should not be showing such kind of generic message. You should be showing very specific message. So for example, divide by 0 is not allowed, or numeric values are only allowed. These kind of specific information will help the user to understand, okay, what mistake the user has done. Whereas when you say some unknown error occurred, the user might not know what has gone wrong. So ideally you should be narrowing down the issues and putting the except block specific to that. So now we have another block called else. So that will be executed only once there is no exception. So instead of printing this here, let me say that result is equal to a divided by b. Now in the else block, I will say print result is result, and I'll just remove this line also. Okay, let me execute this. So if I say 4, if I say 6, and the result is this, because everything was good. If I try to give 3 and some EFG, it will say only numeric values are allowed. And if I say 5 and 0, it will say divide by 0 is not allowed. So now you can see this particular statement, which is there to print the result, will be executed only if there was no exception. If everything went fine inside the try block, then only the else block will be executed. So now you can see how these statements are put nicely, wherein you are calculating all the things here, and finally the result you are printing in the else statements, because only if a result was calculated without any exception, then only the value should be printed. Otherwise this statement can be easily skipped. So this is how you use the else block. And finally you have one more block which is called finally. So now this will be like, this will be executed always. So now if you see the various scenarios, wherein first is the happy path where everything went well. So one is 4, one is 3, and you see the result is printed. That means it went inside the else block, and then it prints this will be executed always, that is finally gets executed. You see one more scenario wherein the exception occurs. So maybe I'll just enter 4 and I'll say ABC, and it says only numeric values are allowed, but still the finally block executes. So irrespective of whether everything went well or whether there was an exception, finally block will always be executed. And people coming from other programming languages like C# and Java might be thinking like, we can have try and finally without the except block, or we can have try and else without the except block, which is possible sometimes in language like C#, where you can have a try and finally block without the catch. Whereas here, maybe you can try it out, because you will see unexpected results. So I will not get into the details now. I'll leave it for your experimentation, where you can try out all the combinations. But I'm sure compared to those languages, you will see some different behavior here. Now, apart from these blocks, we have one more scenario related to exceptions, wherein you want to execute, or you want to throw an exception yourself based on some condition. So it is not an exception scenario for the system, but for your business logic, for your program, you think that is an exception and you cannot proceed further, then it's better to throw an exception so that your execution gets terminated. For example, you are taking an age and you are saying input enter your age. So now I want to convert this into int type. So I will convert it into int. So obviously there will be a potential value error chances here, which I'm just ignoring as of now, but ideally you should be enclosing this also inside a try block, because while converting the value, if this throws an exception, then your program will get abruptly ended. But for this example, I'm just skipping that. I'm not using a try block, and I'll be entering only a numeric value. But I want to show you something else. So now when you are entering an age and you want to proceed further, something related to that, maybe print hi, you are maybe a formatted printing, and I'll say age years old. Now you want to print like this. So now when I execute this, what I expect is if I enter maybe 23, it says hi, you are 23 years old. So this is a simple example. Now since age cannot be a negative, but there are chances the user enters a negative value, and even if you use a try catch block for this, it will still execute fine because even a negative value is a valid integer value. But for your logic, since you are asking for an age, and if someone enters a negative value, it's actually an invalid input for your logic. So such kind of things, for system it is not invalid, but for your business logic it is invalid. In such case, you can stop the execution of the program and stop proceeding further by raising an exception. So for that, I will do a check here. If age is less than 0, if someone enters a negative value, in that case I can use raise. So the keyword is raise, and I can say exception and say age is or age cannot be negative. So this is an exception which is explicitly thrown by us. So now in this case, when you execute, if I say 23, it says hi, you are 23 years old. Whereas if I enter minus 23, now it will throw an exception saying that age cannot be negative, and it will abruptly end your program. It will crash the program. So in applications which you are developing with a UI, maybe a web application or something, usually what happens is this particular calculation and logic will be happening inside your control logic, whereas finally the output will be shown as a message box or in the UI on the web page. So there usually these exceptions which are occurred will not be handled internally, whereas it will be handled at the presentation layer, that is on the UI layer. So there you might have a try catch, and where you might be catching this exception, and this particular message might be shown as a message box. Whereas in the console, when you are seeing here, you might see that this particular way of showing the error is not really good for user, because it is showing the file and the line number and all those things. So this is useful for the developer, whereas for the user, definitely at the UI layer, they will be catching this exception and showing a message box with this particular message which you have passed as part of exception. And it is not that you have to raise only exception type. You can be more specific. Like for example, this was actually a value error. So you can say raise a value error, and instead of an exception, it will go as a value error. And you can, on the presentation layer, you can catch it as a value error. So now if I execute this, enter age minus 34, and now you can see it comes as a value error. In the UI layer, you can specifically look for these kind of errors, and you can throw such specific errors from deep inside your business logic. So I hope the concept of exception handling is clear in Python, and this will be used very widely when you are doing real-time programming. If you're finding our videos useful, please do consider subscribing to the channel and hit the bell icon so that you get notified for our further videos. In case of any doubts in any of the videos, please post your doubts in the comment. We will help you there. And in all these videos, we are posting the GitHub link for the code files in the description. So you can just go to the GitHub links and download the files and execute it yourself. Thank you.